All right, and we'll go through today's presentation. So today we're going to be talking about ROS-BAG, ROS services, and ROS actions. It should be a relatively short meeting, I think, in part because you guys have already seen ROS-BAG, so you pretty much know what it does. But also the topics are not super crazy today. So let's get into it. First of all, we've got ROS-BAG. So you already used this. Originally, this lecture was supposed to come before the project, last week's robotics project, which did use ROS-BAG for playing back data. But that said, we'll take a little bit of a deeper dive here. So the idea is that it's very helpful in robotics to log some sort of data about what's happening in your system, right? And often you want enough data so that you can reproduce whatever is going on in your system. So for example, if you've got calculations running based off of vision, based off of the camera, right, the camera image that the robot sees, you might want to record that camera data, and then that will let you play it back later, right? So this is very, very useful thing to be able to do, right? And in general, at any serious level, if you're doing robotics, you need this. You need to be able to run against the same thing so that you can debug. You need to be able to run against the same thing to test improvements to your algorithm without putting them on new robots, right? There are like 1,000 different use cases. So in ROS, everything that you have, or all of your data in your system, right, is already going through ROS topics. So the idea of ROS-BAG is that you can just record every single message in a topic along with the time at which it was sent, right? And that gives you a very powerful system for recording and playing back data, because all of your information, I mean, realistically, right, the important information, the inputs and outputs of your system are going to be stored in ROS topics, right, or in messages sent through ROS topics. So being able to do this gives you a lot of power. We've been over this slightly, but some of the use cases for BAG files are recording runs for debugging. So if you have a competition run, you almost always want to record it. And so that'll let you, if you run into any issues, you can just play the BAG file back. In addition, it's very useful for testing new algorithms against real data. So you saw that with, I think, with the computer vision exercise, right, where you were testing, or you were trying to, I guess probably a lot of you haven't started that, now that I think of it, because that was last Saturday's. But if you have started that, you notice that that uses ROS-BAGs. It uses a recording from Rubber Racing's robot, right? And you can basically just continue to iterate against that data until you have something that you're actually willing to put on a robot. It's also useful for, like, you could use it to record sensor data for ML training. So if you're trying to train a deep neural network, like we were talking about in the first week of robotics, right? That data all has to come from somewhere. This is a somewhat convenient way to get it. There are a lot of other use cases. And that last one is a little bit sketchy because it has to be translated into a different format for you to actually use it. But point is, it is very, very helpful to have a convenient way to record data about your system. So using ROS-BAG is very simple. Sorry?
We have a question in the chat.
Oh, yeah. Does recording data ever slow down any processes? So in theory, it can. It really shouldn't. So the case where I would see it, like, it's not going to be problematic. It can lose data if you if it goes too slowly. So if other things are basically running and spending too much time running, and it can't keep up with the new messages that are being pulled, sometimes ROS-BAG can lose data, but it's very, very unlikely for ROS-BAG itself to slow down the other nodes on the system. I mean, I'm not going to say it's impossible. It's theoretically possible, but it's pretty unlikely. Yeah. All right. Yeah. So if you look so far, what you've learned in terms of communication between multiple nodes, right? You've seen that you can create a topic and send messages from one node to another through that topic, right? And that has a couple of restrictions. All of those messages have to be the same type. But other than that, it's pretty flexible. It can go to arbitrarily many listeners, and you can have ultimately you can have arbitrarily many talkers sort of publishing to the same topic, right? It's sort of a flexible format. So what we're going to talk about today is a pretty different model for communication. If you look at topics, right, those are sort of unidirectional. You're sort of spamming out packets in one direction. You're sending out new information from the talkers, but you're not actually waiting, like you're not registering that to like any information that comes back from the person to ensure that they received it or to get any results from them. So the services thing that we're going to talk about today is sort of a different model of communication between nodes, and it allows you to ensure that your message is actually received, right? And then also it allows you to get some response from that server or from the person who the recipient will say of your message. Now, a couple of notes. That was a very weird way of framing services. The way you would usually call them is remote function calls or remote procedure calls. So the idea is that any of these clients are able to call a service on the server, and that's essentially like calling a function from the client, right? It's just that it's a function that needs to go from it, instead of being a function that's in the same process, it needs to go to that other node, to ask it, that other node needs to respond to that, right? So it needs to do the computation, and then it needs to send back the result of that computation as the sort of return value, right, in the response. And this is all built on sort of regular ROS topics in a sort of non-transparent way. So from your perspective as the user, right, all you care about is that you can send a request and you can get a response from the server. And then when you make a server, right, all you care about is that you accept requests, which are ROS messages, and you get responses, which are ROS messages. So this is very similar to the message format, but you can make a custom service with a .srv file, right? And what a .srv file is it's essentially a description of the request, essentially in the exact same format as ROS message. 3 dashes to sort of separate the request from the response, and then a description of the response in ROS message format again. So this is an example of a service that just reverses a string, right? That's a pretty trivial service. You would not want to usually incur the overhead of a service because it is a lot of overhead in both in work that you have to do to make one and also in speed. So there's really no reason to do it for something as simple as reversing a string, but it will serve as a useful example. And then if we want to actually implement it, we can say on the client side, or we'll start with the server side, it's going to work off of a callback, right? And if you remember from subscriptions, right, when you want to make a subscriber, you pass in a callback function, right? And that callback function is what gets called whenever somebody publishes to that topic. It's pretty much analogous here, right? You've got a callback function that gets called whenever somebody makes a call to that service. Whenever somebody invokes or triggers that service, you're going to get this callback function called. You're going to get in the request, and it's going to be your job to fill out the response. So in this particular implementation, right, I've got just a little call to a function that reverses the string in the request and puts it into the string in the response. Yeah, nothing particularly complicated here. And then you also want to return true to indicate success. Now that I read this, I'm 99% sure it's actually going to seg fault, but it'll serve as a useful example. So as a tangent, the part that would seg fault is this reverse copy is going to put things into an empty string, and it's not going to be happy about that. Anyway, ignoring the aside there, you can actually advertise this service, right, by creating this my service, or whatever you want to call your service, and passing in that callback. And you just call this on a node handle. So as long as you have a node handle, you're able to create a service. Then on the client side, and I apologize that these are slightly out of order, you can just make a object of this myPackage : reverse string type. You can set its request, right? So in this case, we're setting its request string. Remember, we had this string called original. I'm setting that string original in the request to race cargo's vroom. And if I call that service, right, or I am going to call that service, and in this case, I'm calling this service called reverse string, which actually should have matched up with this my service. I forgot to actually change those to match, but that will print. So that will first that will call the service, right? So it'll, if you jump back to this model, it will send a request to the server, right? The server will invoke this callback. The callback will fill up the response variable. It'll return true to show that it succeeded. It'll send that response all the way back, and then the client will get that response, and the client, so then this call function exits, right? And we see, if that call function returned true, well, that call function is actually just going to return true for success, basically the same as this callback. And we're going to see got reversed string, and it's going to be the reversed version of race cargo's vroom. So yeah. Any questions about services? I think we'll see. Okay, doesn't look like it, so we'll move on. So in essence, a service is just a function call over ROS topics. It allows you to offload calculations to another node. A very common use case, well, first of all, you'll see services in some cases. They're not super common in a lot of our code, but you'll see them, for example, in interactions with GUI nodes, right? So if you have a base station or a GUI that's just acting as the user interface, you could have something like, for example, in RoboCup's case, right, we have a button on our GUI that just starts all of the robots, right? It starts play. And clicking that button actually triggers a service that calls out to something else in the code, right? So things like that, where you have like discrete events that occur, are good candidates for services. But in general, a lot of the time, to make a very broad generalization, if you're just trying to pass data around, you want to use a topic instead. All right. So one of the reasons that services aren't necessarily used like everywhere and a half is that there's this other nice abstraction called actions, right? And if you look at this services thing, right, you could theoretically, there's nothing preventing you from using a service to encapsulate something like move to point, right? And you'll recall that often we don't want to make blocking functions that are like move to point, but you are able to call a service in a non-blocking way, right? Which means you're able to call a service and then repeatedly poll to see if it's finished, right? And if it is, act on the result. So that said, services could theoretically be used for something like move to point, right? That takes a finite amount, not only a finite amount of computation time, but also a finite amount of actual robot time, right? So like we can't, no matter how fast our computer is, we can't move from here to there instantly. There's nothing preventing us from using services for that. However, there's some things that we're sort of missing that we would want in that case. So for example, if we were moving to point, right, we would usually want some sort of feedback that would allow us to tell us, like, for example, if the robot got stuck on the way moving back, or how long in seconds is estimated until we actually arrive at the goal. Things like that, right? So we want feedback. We also want the ability to cancel something, right? So if we are trying to do a move to point action, for example, right, we want to be able to cancel that if we do realize that we get stuck, or we want to move to a new point, we get a new waypoint to move to, any of those things. So actions in general are sort of the answer to that. And the idea of action is that instead of just having this sort of goal and result, or in general, a request and a result, right, request and a response, we have these other lines called status and feedback. And then we also have a way that we can send a cancel message to the server, which will allow us to, as you probably guessed, cancel a previous goal that we set up. So the idea is, and sort of the flow of this is, one, we send a goal, right? Two, we repeatedly get status and feedback messages, right? That basically tell us, they tell us whatever information the action server wanted to pass back, right? And then at the end of the action, so for example, when we've actually hit the point, we get some result, right? So this is pretty much just a summary of what I said, but I'll sit here for a second. Any questions about what we're trying to do and what the motivation for actions is in this context? All right. So now that I gave you this very nice little clean diagram, right, I'm going to ruin all that by showing this very complicated diagram, right? And this is the state machine. Hopefully you guys remember state machines because they're coming back. This is the state machine of the action server, right? And of a particular goal going through the action server. So something to note is that, at least in the most default sense, or the most general sense, actions are tracked per goal. So in a lot of the case, we would want to track actions per server, but at the base level, we're just tracking per goal. And what this means is that you could, in theory, at least again, if you didn't explicitly forbid it, you could have multiple move to point actions going on at once. Now, for something like move to point, you would usually want to forbid that, right? But that does at least illustrate how they're set up. So the reason for this is there are some actions where you might want to be able to have multiple of them at once. For example, if you have, this would be, I mean, a lot of their examples are a little bit weird, but for example, if you had an action that did a computation, right? So for example, an action that every second does a element of the Fibonacci sequence and spits that back on feedback, you could use that, right? As and you can do multiple, like, okay, now I want the Fibonacci numbers up to 15. The 15th one, right? Now I want the Fibonacci numbers up to the 20th, and those could be separate goals. That's a sort of weird example, but it does work. So in general, what the state machine for a single goal going through the pipeline looks like is you receive the goal, and then it goes into the pending state. The server is then either able to reject or accept while it's in the pending state, right? In addition, the client at any time is able to cancel. So if you reject it, it goes to the rejected state. If you accept it, it goes to the active state, which is pretty much just running. And then if you cancel it, it goes to the recalling state. And then active is where most of the work happens. In general, your actions should spend most of their time in action because that's while it's actually, basically while the server has acknowledged that you're going to move to the point, and the robot is in transit. It is moving to that point. So you can cancel an active request. Point it goes to the preempting stage, and then eventually goes to preempted. Yeah. All of these all of the blue ones out on the outside here, these are terminal states, so these are like where it ends up. This is the only success state, but yeah, hopefully that makes sense. So we've got a question. So the actions are basically the robot actions that in most cases require a feedback loop. So sort of, yeah. In general, they are it's any like finite horizon is what we would say, action that you want to take, right? So something that will, I mean, usually you'd consider an action as something that can eventually be completed. So if you are, I mean, if you're like in a hypothetical robo racing environment where you're trying to just drive around the lap, like drive around the track forever, right? I know that's not actually how competition works, but if you're hypothetically trying to do that, you could just, you usually wouldn't do an action for that, right? Because that is going to go on forever. There's no reason to call an action for that. But if you're doing something like move to a waypoint, right, drive to a particular goal pose, that would usually be an action, right? If you're doing something like catch the ball in RoboCup, right, you're trying to capture the ball, that should be an action because there is a defined end time to that where either it will catch the ball or it will fail to catch the ball because the ball will go out of bounds, right? So yeah, I've got, but yes, in general, like it is something that requires a feedback loop and that will take a period of time to execute, right? So we've got some more examples of actions from actual RoboCup or RoboJackets teams. In RoboNav, they use a move to waypoint action, I believe. Correct me if I'm wrong. I looked very briefly.
It's move to waypoint. Yeah.
Okay, cool. I looked very briefly at your code while I was putting these slides together, so it's very helpful that I messed something up, but I think that's correct. And then RoboCup is, well, currently in progress of porting to actions, but the way we have planned things out, there's going to be a separate action, for example, for catching the ball, capturing it, right? For passing the ball from one robot to another, for moving to a point, and so on and so forth. There are actually a bunch of other different actions that RoboCup robots can take, because I guess there's sort of a bigger variety of like interactions with the environment that happens there. It's not a like single goal that you're going down. So yeah. Robo Racing, I believe, does not have any actions for sort of partially for the reason I think I mentioned earlier, but am I correct there?
Yeah, we don't really use them.
All right, cool. So Ross does have a couple of actions built in, just like it's got a couple of message types built in, although its variety of actions that are built in are far, far smaller. So you'll pretty much always, if you're using actions for some reason, or for one reason or another, you'll always pretty much be making your own custom action. So this is an example. It's sort of, actually, it's basically just a stripped down version of like what you might see in for example, RoboNav's code base, right? Or even in RoboCup's code base, where you're trying to move to a particular position and orientation on the field, right? And you might have some target pose, right? And recall that pose is position and orientation. You might have some error threshold, so basically when it's considered done. And this is important because some movements might need to be more precise than other movements. So that's what you get, what you send over in your goal, right? Your result is going to be something along the order of like the final pose that you end up in, as well as the total time that it took to arrive at your goal from the initial goal that you sent out. Feedback is going to be whatever you send periodically on the way, right? So this could be something like current error, right, and current time to goal or current expected time to goal. These would be like sort of common-ish ones. It totally depends on your actual application here. And it's whatever the caller of this, right, whatever the client is going to need to get back, whatever information it needs about the internal state of the motion planner or whatever you're calling the action for. I've got a slightly more contrived example, actually substantially more contrived example here. This is absolutely blatantly ripped off from the Ross Action Lib documentation, which you can check out if you want to. But essentially it is saying, okay, our robot is a dishwasher robot, and we place dishes in the dishwasher and we turn the dishwasher on, and that gives us some useful information, right? That's like the overall lifespan of the action, from putting dishes in the dishwasher to turning the dishwasher on to waiting for it to be done. That's the lifespan of our robot. So what we do is we, in our goal, we say, okay, we want to use dishwasher number 1. And then we're going to repeatedly get back out. We are 10% through the way of that whole process, right? We are 20% of the way through. We are 50%, 80%, and so on, right? And we're going to get that information back periodically in a feedback message. And then simultaneously at the end of things, right, or not simultaneously, the opposite of simultaneously, after all of that is over, right, we're going to say, okay, we have total cleaned 30 dishes, right? We had 30 dishes in the dishwasher, and that was our result. So it's a very contrived example. I'm pretty confident that we're never going to see this in any RoboJackets robots, but it is an example. And it also allows me to steal a bunch of code. So this is an example of an action client, right? And an action client, if you remember, is the thing that sends the goal, right? It sends a goal, it waits for the goal, or either that or a timeout, and then it checks whatever the result is to make sure that it succeeded. So in this case, I'll actually turn back on my laser pointer. We're going to create an action client, right? That's this line. The type of action clients are like it's action lib, : simple action client. It's templated upon chore, or whatever the action type is, right? So in this case, the action type is chores do dishes action. You'll also note that we included this do dishes action file, which is the file that is generated from this custom action file. So this would have been do dishes.action, and then that generates this do dishes action.h file. Then we're going to want to wait for the server to boot up, right? And if the server is already booted up, this is fine. This doesn't do anything. It basically just checks and returns. And then if it can't find the server, it'll just pause until it actually can find it. Oh, also, one thing to note, this is the service name, right? And this second argument, this cryptic little true over here, means that the client is going to run in a separate thread, which means that we don't need raw spin. It makes things a little bit more convenient for examples, although for real code, it doesn't really matter a ton. So we wait for the server, we set up our goal, right? And in this case, we're going to create a do dishes goal, and we're going to send it, or we're going to set it up with like the particular dishwasher ID that we actually want, right? So we'll say goal.dishwasher ID is equal to 5 or something, I don't know. And then we will send that over the client, right? We'll use the client to send that. We'll wait 5 seconds for a result. 5 seconds would be pretty short to do dishes, but maybe this is a very good robot. And then this wait for result is going to either time out or it's going to succeed, right? It's either going to get a result from the action server, or it's going to fail, right? It's going to spend 5 seconds and it's not going to succeed. So if it actually did succeed, we will get this state, right? This client get state is succeeded. And this succeeded can be any one of these, right? Or any one of these terminal states once you've already finished, right? If it's still not finished, it's going to be one of these pending, active, recalling, preempting states. But we care about the case in which it has succeeded. So if we look back at our code, right, in the case that it's succeeded, we can print out a little status message. I apologize for the use of printf. This was not adequately checked over, but printf is a function from C that prints out something. It's pretty much the same as cout. And then we're just going to print out the current state of the system. So this is like a very simple, very, very simple action client. You'll get to implement a slightly more complex, although not that much more complex, action client in one of your exercises for this week. So the other half of the equation is an action server, right? And in this, it's sort of analogous to I guess a subscription, right? In that you have to give it a callback, as you might remember. So we create a server, right? We need a node handle for it. We need what the name of the action is, right? We need to figure out a callback for that to bind to. So in this case, we're going to use this kind of ugly syntax. In general, almost always, if you're looking this up, you're honestly probably just going to, well, sorry, if you're using this, you're probably just going to have to look it up. This syntax is always obnoxious, so yeah. And I believe in ROS1, to make it even worse, stdbind does not work. Am I correct there? I can't remember how ROS1 works. Anyway, at this point, you'll also notice that we're setting this false, this separate thread variable, right? So that means that we are going to need ROS spin. And that's fine because we're okay with spinning forever. You know, our server should spin forever. Anyway, we start it up and then we spin. And then if we look at this callback function, all it's going to do is it's going to, well, currently all it's going to do is set succeeded on the server, right? And that's how you tell the server, or tell the server object to send back something to the client that says, hey, this action is over. It went to the succeeded state. We're done. You should actually, if you're going to have this as anything useful, have something that happens that goes on that uses this this goal value to produce some useful result. You can send feedback messages through that, and so on and so on. Yeah. Any questions on this code? And again, you'll get at least practice with creating an action client in the exercises for this week. All right. If not, that is about all I had for today's lesson. So like I said, relatively short. Any questions about, I guess, anything that I went over today? All right. If not, please remember to click the attendance link. And other than that, you are free to head back to your breakout rooms. So, see y'all in a bit. Also, I have a classroom link that I will send to your sub-team leads, so they can disseminate that to you.